Hello. In this video, we're going to answer some questions, and it's really pulling together a number of concepts that we've talked about all into one problem. So the equation gives the amounts in parts per million of PCBs in a contaminated site M months after a cleanup process begins. And at the very bottom of the screen, you see that the polychlorinated, biphenyls, that's the PCBs, and there are man-made compounds, and they were used a lot of things, and were banned in the 1970s because of the environmental concerns. So some of the dumping sites where we have electrical equipment that has been, part of a landfill, etc., have provided this contamination, and then if that site wants to be used for something else, it really needs to be cleaned up. So first off, just looking at the equation, looking what I know about this equation definitely fits the NPAT formula. And it's kind of odd that they used P here, but they're thinking PCBs. So the letters of NPAT, I'm just matching up above the formula here. So how many PCBs were initially there? Well, that's the P in NPAT, and so that is 300. Next, is it growth or decay? That's looking at the A value, and the A is less than 1, so this is decay. And I know that because A equals 0.86, which is less than 1. What is the decay factor? Well, that's 0.86. What does it mean? Well, that means I have to change it to a percentage, so 0.86 times 100 is 86% remains, and our time here was a month, so at the end of the month. By what percent are the PCBs growing or decaying? So I'm going to cross out growing because we've already decided they're decaying. And to figure out the percentage of decay, I need to know how much this is different than 100. So I'm going to take 100% minus 86%, and that shows me that it is a change of 14%. And so this is decaying by 14%. So I'm going to rewrite as a word problem. So we started with 300 PCBs at the site. 14% are removed. Each month. Via cleanup process. So the key in rewriting as a word problem is to give the starting amount, so we did give that, and to give the constant percent change. So I have this 14%. I have are removed, which I'm hoping communicates that they are decayed, and so I would use the 1 minus the 14% as a decimal if I was writing the equation based on that word problem. And I also want to give the time frame, so I did have to mention that that 14% goes with a month. Now, the next two problems are dealing with a change in time. So the formula gives it, we're asked to give it in weeks, and we're asked to give the formula for years. So over here to the side, I have a chart to help me organize and think through this. So in the original problem, my A was 0.86, and the time for that A value was a month. So the first thing I'm asked to do is to figure out the A value if the time frame is a week. So I have to think about a week is what fraction of a month, because this is shorter. So a week, given 4 weeks in a month, is 1/4 of a month. And I'm always comparing back to the original. So 1/4 of a month means I would take 0.86, and then because time is the exponent, I use this as an exponent, so 1/4. And I do that on my calculator, and I got 0.963. All right, so it also wants me to think about per year. So a year, and I have to compare to the original month, so a year is 12 months, so it is 12 times longer than a month. So if I think about finding my A value for this, I take my original A value of 0.86, time is the exponent, and this is happening 12 times, so I use an exponent of 12. And when I put that on my calculator, I got 0.164. All right, so then to rewrite the formulas, the first one, the PCBs, so P started at 300. My decay factor for the weeks is 0.963, and I'm going to use W as my exponent for weeks. And then the formula for years, P, the PCBs, started at 300. I use my decay factor, 0.164, and I'm going to use Y up here for years. Now, if I make these into percentages, I think that helps me make sense of them. So at the end of the year, even with all this cleanup effort, there are still 16.4% remaining. And at the end of the week, with cleanup effort, there's still 96.3% remaining. And so in context, like at the end of the month, there was 0.86% remaining. And so we can see how using the exponents to adjust the growth or decay factor for the time works out and makes sense in the context of the process.